Well, good morning. I don't know if it's morning for you, but it's for me. So I've just gotten up and I decided to record another video lecture because it's so much fun for me to do this. And the topic of this lecture, I will talk about recursion a bit more and also about data structure. So this is basically an extension to what I talked about regarding functions. The last lecture was about algorithms, and a function actually is a kind of subprogram that usually computes an algorithm. So functions are not expected to end in an endless loop, but they actually could end in an endless loop. So it is not like this that a function is always behaving as an algorithm, but usually you encapsulate algorithms as functions. So uh, I was talking about mathematical functions. So if you have, for example, function of x is 3 times x plus 2, then this is a mathematical function. And a function in programming is also called a method in object-oriented programming. So this is also supposed to take an input parameter or several input parameters and ultimately get you an output parameter. And if you do the same thing with a function that doesn't return an output parameter, it's also called a procedure. But this is actually a term that is not used much more anymore in computer science and computer programming, because this refers to programming languages prior to C. In C, there was no difference between functions and procedures anymore. So procedure actually is a void function in C. I mentioned recursion last time, and I just want to add that recursion is not just about calling other functions, because it is actually trivial, but about calling the same function in the function. So, for example, if you want to compute the faculty of a number, then you can implement this as a recursive function. Because by definition, for the number 1, the faculty is 1. And for any number greater than 1, and I'm talking about integer numbers, you can obtain the faculty by multiplying this number with the faculty of this number minus 1. And so you have a recursion, because you can compute the faculty by a function that calls itself, just with a different parameter. And actually, there is also the concept of tail recursion, which is important in some programming languages, for example, Scala. They say that you should try to make your functions tail recursive, and this is because a tail recursive function is a function that ultimately calls itself, but nothing else. So the faculty as I presented it here is not tail recursive, because when I say you have a function of x and you multiply it with the function of x minus 1, then you have x times function of x minus 1. So it is not that the function call is isolated. So a way to do this is to use some sort of accumulator, which is a variable that stores the results computed so far, and then you have the parameter. And what you do is you check if the parameter is 1. In this case, you restore the accumulator. Otherwise, you simply call the function with the accumulator multiplied by the parameter and with the parameter decreased by 1. So you should try this. It works for faculty. Maybe it would be easier to understand it if it just took a look at a simple function that adds 1 plus 1 plus 1 plus 1 and is n times. So the accumulator actually, first the accumulator is 1 and the parameter is n. So actually the accumulator also passes a parameter, but when I say the parameter, I'm talking about the parameter in a stricter sense. So you have two parameters actually, the accumulator and the actual parameter. And so you have 1 being the accumulator and the n being the other parameter. And so you check if the other parameter is 1. If it is not 1, then you call the function again, but you add 1 to the accumulator, and you decrease the actual parameter by 1. And so this is the trick, and this is the same with the faculty. This is the way to make it tail recursive, because ultimately you only have a call to the same function, and you can actually do this in an iterative loop. If you already know what a loop is, because I haven't talked about this yet, but it's actually one of the most simple concepts of computer programming. So maybe I should mention it here, because it is so basic. A loop actually is just a way in imperative programming, especially. So you do something, you do some commands several times, and one easy thing would be you want to print out hello world 10 times. Then you could do this with a for loop, which initializes a variable, let's call it I, with 1, and then in each iteration it increases the variable by 1 until it reaches the value 10. And this could be a for loop. For loop is only one of many possible loops that exist, and actually they are logically equivalent, so you can easily express a for loop. Well, you can express a for loop as a while loop, and in C you can also express a while loop as a for loop, the other way around. But this is mainly because the for loop in C and related programming languages has a very powerful syntax. In other programming languages, the for loop is actually less expressive than a while loop. A while loop is simply you have a statement which has to be fulfilled. So all the comments are executed if the statement is fulfilled, and then after all the comments have been executed, it takes a look if the statement is still fulfilled, and in this case it executes the commands again, and so on until the statement is not fulfilled, if it is false. So a while is also related to an if condition. An if condition, however, is not a loop. A if condition just checks if the condition is fulfilled, and in this case it executes the commands that are in the brackets. So this is a conditional statement, but it is not a loop. But it is related to one thing to another. And what I also wanted to talk about in this lecture is basic data structures. So you when you have a function, usually you define a data type for the input parameters. If you have several input parameters, you can have different data types, and for the output parameters. And I mentioned sorting functions. So if you have a sorting function, then The parameter is actually a list of whatever, for example, decimals, or you could also you sort something else. For example, you could sort strings, so sequences of characters, words. Yeah. So it's in a list of primitive, but not only of primitive, it could also be a list of more complex data types. So the parameter can be actually of a complex data type, a very complex data type. It could even be an object, or in some cases it could be a function. And in the sorting, the parameter is a list, and also the output is a list. But usually programming languages have some primitive data types. Many programming languages have integer variables, so these are variables without a comma, and they have decimals. There's variables with a comma. There could be fixed point or floating point, so these are variants of decimals. And you could also have characters and strings. They are sometimes considered primitive data types. But then you could have lists, for examples. You could have arrays, and also C already knows the data type struct. So what I haven't talked about yet is pointer. So pointer actually is an integer which stores the address of another variable in the computer. And so this pointer variable kind of points to this other variable. And you can indirectly manipulate the other variable. So what is if we have a struct, so a compound data type that contains several primitive data types. A struct, it consists of some primitive data type and a pointer. Then you can make a linked list. And a linked list is a data structure in which you can, well, express a list. But there are several ways to express a list, and the linked list has the advantage over others that you can easily remove and insert items from the list. And this does not affect many of the other list members. So, for example, let's say you have a member A of a linked list and a member B of the linked list. So the pointer of A, the pointer that is inside inside A points to B. And now you have a new item X which you want to insert at a position after A. So it should not be A and then B, but it should be A, then X, then B. So what you do is you save the pointer to B in a temporary variable. Then you overwrite in A the pointer so that it doesn't point to B, but it points to X. And then in X, you insert the pointer to B. And this is all you need to do in order to insert a new element in a linked list. And by contrast, if you have an array is actually a space in memory reserved for several variables of the same data type. For example, you have 10 variables. This is an array with 10 elements. And in an array, actually, it's much harder to insert something because usually you can only overwrite existing elements. There are also dynamic arrays in some programming languages, so you can resize them. So if you know you have 10 elements and actually you want 11 elements, you can resize them. But if you want to insert the element, it can only be easily done if you insert it at the end of the array. If you want to insert a number in the middle, then you have to move the other elements so that you can insert the new element where it should belong to. And this is computationally much more expensive than with a linked list. But on the other hand, if you want to just retrieve an element, let's say you want to retrieve the 8th element, then it is far faster to retrieve is with an array than with a linked list, because in a linked list you usually start with the first element and then you go to the point of the second element, you get to the point of the third element, and so on. And with an array, you know that the address of the first element in memory, and you know how much space each element occupies, and so you can easily compute the address of the 8th element, for example. So that was it for this lecture. I hope you enjoyed it. I hope you didn't find it confusing. You might listen to it again if it was maybe a bit confusing or a bit too much. So thanks for watching, and I hope you enjoyed it.